So, first of all, let us check the coordinate system between the relationship between the polar coordinates to the Cartesian coordinates. So, for example, you're given that there is a point P having the polar coordinates as r, comma theta, and you're interested in checking for what sort of coordinates that point will have, the point P will have in the form of x, comma y, right? So, let us really check in the Cartesian plane. For if you have a Cartesian plane like this, and the point P is right here. So you are given P in terms of r and theta, and you want to find P in terms of x and y, right? So if it is given in terms of r and theta, what do you have? That you have this much distance OP is your r, this is r, and this is theta, right? And to find x and y, let us just plot this thing here. Let's say this is the point M. So when you'll consider the triangle PMO, what is the value for OM in terms of r and theta is this is the value x, means you are interested in finding the value of or the length of this line segment OM, right, which is precisely your x, and you are interested in finding y, which is nothing but PM, or you can even think it like ON, right, one and the same thing. So all we are interested in is the distance OM and PM, and we can look for these distances in the triangle PMO. So you can see that OM upon OP is nothing but cos theta, right? So OM is OP cos theta, that is x happens to be OP was r, so it is r cos theta. Similarly, you have PM upon OP is given by sine theta, and which is this PM is equal to OP sine theta, which gives you y is going to be r sine theta. That is, whenever you have a point in the form of the polar coordinates where this is r comma theta, r is the length of the line joining the origin to that point, and theta is the direction. Basically, theta is the angle which that line will make with the positive direction of x-axis. So you can find the Cartesian coordinates by just taking x as r cos theta and y as r sine theta. That is, you can say that the point P, which was r theta, is precisely P, which is given by r cos theta, comma r sine theta in the terms of Cartesian coordinates. Right. So let us quickly consider an example. You're given P as the point which is root 2 comma pi by 4. So let us plot this point first and check what are going to be the coordinates of this point in terms of the Cartesian coordinates. So if this is your Cartesian plane and you have that, how many units you need to travel from the origin? Root 2 units. In what direction? The pi by 4 angle is to be there from the positive direction of x-axis. So when you'll travel positive direction of x-axis by pi by 4 radians, then this is somewhere along this line, right? And what will be your point P? The point P will be root 2 units from the origin, means somewhere here. So this is your point P, which is root 2 comma pi by 4, and you want to evaluate the Cartesian coordinates of this point root 2 comma pi by 4, and it will be given by x will be r cos theta. Now your r is root 2 and theta is pi by 4, so it will be root 2 cos pi by 4, which is precisely 1, right? And similarly, y will be again root 2 sine pi by 4, which is precisely 1 again. So the point P is 1 comma 1 in the Cartesian plane, right? The Cartesian coordinates of the point root 2 comma pi by 4, which was given in the terms of polar coordinates, is the Cartesian coordinates are 1 comma 1. So this point P can also be written as 1 comma 1 in the Cartesian system, right? Is there any doubt so far?
No, ma'am.
All right. So let us now consider the other way around. That is, we are given the Cartesian coordinates and you want to go to the polar coordinates. Right. So you're given P as x comma y and you want to evaluate P as r comma theta. Means using these x and y, you want to find what r and theta would be so that you can go from Cartesian coordinates given to the polar coordinates, which you basically need to find. So let us consider the plane again. So in this coordinate system, you have a point P given in terms of x comma y. That is, this much distance is your x and this much is your y. All you are interested in is the length r and the angle theta. So this r, let's say this is again m and this is o. So this r can be evaluated using what? Again, look at the triangle PMO. You have that OP square is going to be OM square plus PM square. Or rather, OP was R square, which gives you x square plus y square, and you have that R is going to be x square plus y square, the root. Right? So the R is given by the square root of x square plus y square. We intend to take it positive because generally how do we take R is the units, the number of units which we are traveling from the origin to reach the point. And we had already discussed if in case R is negative, we can always take the supplement angle of the angle theta which we'll get. Right. So R is also concerned with the direction, but as of now we are taking it to be positive so that we can actually relate it with the number of units which we need to travel from the origin to reach the point. Right. And next up R is there with you. Next you need to find theta. Theta will be, have a look. You have x with you have y with you. So how can you relate theta with x and y is the question. So theta can be related with x and y in the sense you can think about tan theta. Tan theta will be y upon x according to the triangle so formed. So your theta will be tan inverse of y by x, right? So your point pxy now becomes in the form of polar coordinates as p of r, which you have obtained as this thing, and comma theta, which is precisely tan inverse of y by x. Right? These are the coordinates in form of polar coordinates. So let us consider an example for this. So you have that if given in terms of x and y, r will be x square plus y square, the root, and theta will be tan, tan inverse of y by x. Right. So let us consider an example here. Given that P is the point minus 1 comma 1, you need to find the polar coordinates of this point P. So let us first plot the point in the Cartesian plane so that we can have a look. The point minus 1 comma 1 will be here. Right. Let's say this is the point minus 1 comma 1, which is P. So you're interested in finding r and theta so that you can plot this point in terms of the polar coordinates. So you can see simply see that r square was x square plus y square. Right now your x is minus 1 plus y square, that is simply 2, and you can say that r is going to be square root 2. That is, this particular distance is going to be square root 2. And in what direction? In this sort of a direction. Means theta is going to be, or rather tan theta is y by x, which we already know, and the value is minus 1. And for what value of theta tan theta can be minus 1? It will be judged by the quadrant where your point lies. Right now you have your point in the second quadrant. So tan theta is minus 1 for what value of theta which will take this point to the second quadrant? Theta is going to be, isn't it, 3 pi by 4. So you have your point P, which was minus 1 comma 1, now as root 2 comma 3 pi by 4. Right. So this is your,
Can you also write minus pi by 4?
no, minus pi by 4 will be somewhere here, but your point lies in the second quadrant.
Okay, so it has to be in the same quadrant.
It has to, like, you have to really go to the quadrant now wherever your point was there. If in case it would have been 1 comma minus 1, minus pi by 4 would have worked for you. Right? You have to
Okay.
really relate,
Understood.
really have to locate the quadrant where you want to reach, like wherever your point existed. Right? And there is one more thing,
Okay.
that you can reach this particular quadrant by completing circles. Like once you have reached this quadrant by taking 3 pi by 4 units, 3 pi by 4 radians, and after one more circle, you can reach this quadrant again. After another circle, you can reach this quadrant again. In case you take a circle in the other direction, you can reach this quadrant again. And yes, of course, you have the direction, you have your r as root 2 units, so you can reach the point. So that means if you'll add or subtract the number of circles in your theta, you'll reach the same point again and again, right? So this is almost, I can say this is an equivalent point to the one given by 3 pi by 4 plus or minus some circles. Circles are, and a circle is given by 2 pi radians. Two circles will be given by 4 pi radians, and similarly, circles will be given by 6 pi radians. And in the other direction, they'll be given by minus 2 pi, minus 4 pi, and so on. So it's basically 2n pi type of a structure where n happens to be an integer in terms of positive or negative. Means you can reach the same quadrant by completing the circles in any of the directions. Means you can reach the same angle back with addition or subtraction, or with some attached circles where n happens to be from integers. So this point has the polar coordinate as this as well, and in the form of such coordinates as well. Right? That's not a problem. But and there is one more representation of this particular point in the terms of pi by 4 as well. How? See, you have this structure. Again, let us draw this. You have your point right here, which was minus 1 comma 1. If in case you see it in the terms of minus pi by 4. See, this line is of course pi by 4, that's all right, like this. And if you'll see it in terms of minus pi by 4, means when you're along this direction, you'll have to travel in a opposite direction to the one which gives you minus pi by 4. That is, this point is reached by traveling in minus pi by 4, in the direction of minus pi by 4, but in the opposite direction of the travel, that is, your r will have to be something in terms of negatives. So this point P will also be similar to or the same as minus root 2 minus pi by 4 now. So minus pi by 4 will be related to minus root 2 rather than root 2 with minus pi by 4. That is, if you're traveling in minus pi by 4 wala direction, means you're traveling along this line. And to come up to this particular part, you'll have to travel in the negative sense of r. That is, you'll have to travel from the origin away from the direction of minus pi by 4. So your r will happen to be negative in the other direction. Right? And also we can write this thing again as minus root 2 comma minus pi by 4 attached with some circles where n happens to be an integer. Right? That's how you'll relate it with minus pi by 4 with your r happening to be in negative now. So that's how you can relate the polar coordinates with the Cartesian coordinates. So you can try doing two examples. Let's say one is you would like to convert this point Q to the Cartesian coordinates, and another convert this point Q to the polar coordinates. This is minus root 3. Right? You can try doing these examples for your practice.
Excuse me, ma'am.
Hmm.
Ma'am, for finding out theta,
Hmm.
can we also write, for example, cos inverse of x by r or sine inverse of y by r?
You can do that, but uske liye you'll have to find R first. Yes, you can do, of course.
Yeah, I didn't think about r. Got it, ma'am.
You always can find R first because if you have X and Y, you can reach to R easily. And as soon
Yes.
as you have your R, then you can find using sine and cos ratios as well. That's not a problem. But there can be something like you can take R to be negative or positive. That will depend upon the situation. If you'll take R to be negative, you'll have some theta. If you'll take R to be positive, you'll have some other theta. So I'll recommend to go with X and Y because they are given for you and they are fixed. They are not changing according to your requirement afterwards as well.
Okay, ma'am.
All right. So next up we have once we replace the coordinates from Cartesian to polar or polar to Cartesian, we can also have some relation between their equations. So let's say for example you are given with an equation which is sort of x square minus y square equal to 1 type. I would like to check how this equation will look once x and y are taken in terms of polar coordinates, right? So this is our situation right now. The question is that you want to replace the Cartesian equations by their equivalent polar equations. So given this equation in terms of Cartesian coordinates, you would like to find the equations form the equivalent equation in terms of polar coordinates. So that's simple. You know how x and y are related to r and theta. You can just substitute and solve to get your equation. Right. Now let us see how. You know these are Cartesian coordinates. You want to take into the terms of polar coordinates. Means you want your r and theta to be in picture now. So because r is this x is given by r cos theta and y is given by r sin theta, you can simply substitute them in the equation and check. So this equation now happens to be r square cos square theta minus r square sine square theta, and it is equal to 1. Then you can solve r square cos 2 theta is equal to 1, and this is your required equation in terms of polar coordinates, right? It is simple like this. So let us consider one more example for the sake. Let's say you have some circle. You can identify the circle center in this x minus 5 whole square plus y square is equal to 25. What sort of circle and what is the radius of this circle?
Ma'am, the radius is 5 with a center of 5 comma 0.
Absolutely. So you'll have to now convert this thing into the form of polar coordinates. So what shall we do? We'll again do the same thing. X happens to be r cos theta and y happens to be r sin theta. So you can put the values right here in the equation to get, and you can solve it. R square cos square theta minus 10r cos theta. It is simple to solve, right? And These two terms get combined to give you r square minus 10 cos theta and an r is equal to 0. Means you either have r to be 0 or r to be 10 cos theta. Can r be 0? See, because we want the equation of a circle with the center 5 comma 0 and the radius as 5, can r be 0? What happens when r is 0? What is the situation when you have r to be 0? See, r being
It
0,
will make a point.
it will be
It
just the
depicts
point
the origin.
origin. Absolutely. So as r is equal to 0, you just have the point origin. But what all you need is a circle right now. So you will have to discard this equation. You'll have to discard this relation. Then the given equation x minus 5 square plus y square equal to 25 is precisely this. R is equal to 10 cos theta. Right? So your equation's equivalent form is R is equal to 10 cos theta. And how can you really confirm it? By looking at the equations in the Cartesian form, you can check that it is precisely the circle with the center 5 comma 0 and the radius 5. But when you have it in terms of polar coordinates, that r is equal to 10 cos theta, you can actually take different values for theta, and as theta will change, you'll have the value for r. For example, theta is equal to 0, you have your value of r as 10. When your theta is pi by 2, the r value for r happens to be 0. We'll do this in subsequent sections, but just in review for you, just an overview, how do we will plot these equations in the form of polar coordinates. It is done by using this thing that if r depends upon theta, you'll take the different values for theta and find r, and will plot r and theta, whatever values we'll get in terms of r and theta, we'll plot them as coordinates as we have done. And when you'll have the coordinates, you can join them all to get your required curve. So we'll do this in the next section, of course, but just an overview that you can change your theta to get the value for r and get the coordinates correspondingly as r comma theta and join them to get the curve, and you'll see both the curves are going to be the same. That is, both are going to be the circles with center 5 comma 0 in the Cartesian coordinate system, and corresponding center you can find in the terms of polar coordinates as well, right? So this is how you'll convert a Cartesian form of equation to a polar form of an equation. Also, we can do the other way around. Means you're given the equation in terms of polar coordinate, and you want to convert the equation in terms of the Cartesian coordinate and then discuss the graph. Because Cartesian coordinates are easy to view right now for you. So we'll be having equation in terms of the polar coordinates. We'll convert it to the Cartesian form of an equation, and then we'll discuss what kind of graph it shows. So let us consider an example first. You have that r is equal to 4 cosecant theta. You want to convert it in the terms of x and y. So you know that if you have r and theta in picture, you can have x and y as the relation either x is equal to r cos theta and y is equal to sine r sine theta, or you can use the relation as r is equal to x square plus y square root and theta is equal to tan inverse of y by x kind of a thing. So you can use either this set of relation or you can use the other set of relation. So as of now, have a look. What is better to look for? Just try to form in the manner that you have something which is which is perfectly visible. So you have r is equal to 4 cosecant theta means r is equal to 4 upon sine theta, means r sine theta is equal to 4. And what is r sine theta? Is it visible somewhere?
Why?
Y means you have your equation as y is equal to 4, and that's it. So you have this thing r is equal to 4 cosecant theta represents a line which is y equal to 4. Means it is a line which is parallel to the x-axis and at y equal to 4 units. So that's how you have taken the polar form of an equation to the Cartesian form of an equation. And yes, we have seen that the graph looks like a line which is parallel to the x-axis and passes through the point 0, 4. Right. So that is simple in terms of Cartesian coordinates. Another, you can look for an example. R was 8 sine theta. Now we would like to convert it to the form of something in the terms of x and y. Right now, you cannot straight away see if it is in terms of x is equal to r cos theta or y equal to r sine theta type. So what we'll do, we'll try to look for the other thing, that is r is equal to square root of x square plus y square and tan theta to be something like y by x kind of a thing. Okay. So you have multiply r on both sides, will have r square as 8r sine theta. Right? By multiplying both the sides by r, we have r square on one side, we have r sine theta on the other side. Because r square is visible as x square plus y square, it can be substituted. R sine theta is visible as y, it can also be substituted. So our equation now looks like x square plus y square is equal to 8y kind of a thing. Right? And as soon as we have something like this, we can always use the completing the square method to check for what sort of graph it will show. So the equation which you have is this. You can do x square plus y square minus 8y equal to 0. And by completing the square, how will we do that? You can view it as minus 2 times 4 times y plus 4 square, which is 16 on the both sides. So you have x square plus y minus 4 whole square is equal to 4 square. What kind of graph it will depict?
Circle.
With center,
0 comma 4 and radius 4.
circle with the
Radius
center
4.
0,
Radius 4, sorry.
and the radius is going to be
4.
4. Right. So your equation which was given in terms of polar coordinates r is equal to 8 sine theta represents a circle with the center 0, 4 in Cartesian coordinates, right? And the radius is going to be 4. So you have precisely seen using the two examples. Once you had x माइनस 5 स्क्वायर अभी ऊपर जो हमने एग्जांपल्स कंसिडर किए थे x minus 5 whole square plus y square is equal to 25, and you could reach that it was r is equal to 10 cos theta. And when you had r as 8 sin theta, you had your circle to be like x square plus y minus 4 square is equal to 16 type. Can you notice something from here? If you have r is equal to something cos theta, you have your circle to be the one with the center on x-axis and y with 0. And if you have something sine theta, you have your center on the y-axis with 0 attached with x. So in general, you can see if you have polar coordinates, if you have Cartesian coordinates, that's simple. You can view it simply. It is going to be a circle with the center a comma 0, and the radius is going to be a. Right? You have seen it before in your like high school as well. And if you have another thing, that if x square plus y minus a square is equal to a square type equation is given, then you have this circle with the center 0 comma a, and the radius happens to be a. Now let us compare these with the polar coordinate system. So when you have an equation in terms of polar coordinates, so if you have r is equal to, let's say, 2a cos theta, so you can identify this equation as a circle with center in the terms of Cartesian coordinates now at, because it is cos, the center is going to be a comma 0 and the radius is going to be a. And if in case you have r is equal to 2a sine theta, then it's going to be a circle with the center in terms of Cartesian coordinates at the y-axis. If it is sine, then the center will lie at y-axis, means x is equal to 0, y is going to be this a. Remember, you have to make it in the terms of 2a. So when you have 2a, the center is going to be either a comma 0 or 0 comma a, depending upon you have cos or sine in picture, and the radius is going to be a again. Right? So that's how you can compare your polar coordinates with the Cartesian coordinates and observe what sort of graph or what sort of diagrams these polar coordinates or polar equations are going to give you. Right?
Mom, could you please scroll up a little?
Here?
Yeah, ma'am, just 2 minutes. Done, ma'am. Thank you.
All right. So you can try for a few examples. Given that you have your equation in the terms of xy equal to 2, you may try to convert it into the polar form of equation. And another, if you have r cos theta plus r sin theta equal to 1, you may convert into the Cartesian form and comment about the graph. You can do that right now. You can do this one right now. So can you tell me what would be the Cartesian form of this particular equation?
X plus y is equal to 1.
And what sort of
A
this thing will
straight
be?
line with intercepts 1 and 1.
Absolutely. So it'll be something like this, x plus y equal to 1. Because you can see simply x was r cos theta, so this thing becomes x. And because y was r sin theta, it becomes y. So you have x plus y equal to 1, which is precisely a line having intercepts at 1 comma 0 and 0 comma 1. Right. So another example to try for. You can try solving this. R is equal to 5 by sine theta minus 2 cos theta. So you can try solving for this one. You will have to convert it into the Cartesian form first and then comment about what sort of graph or the diagram it shows. Right? So with this one, we are done with the concept of conversion
Ma'am,
of
what was the answer for the first example?
first one mean this one,
Xy is equal to 2.
xy equal to 2. Okay, so you can you'll have it as I'm writing the answer. You can confirm this. Simply x
Yes,
is
ma'am.
going to be r sin x is going to be r cos theta, y is going to be r sin theta. You have r sine r square cos theta sin theta equal to 2. Just adjust them to reach here. It is quite simple.
Yes, ma'am.
ठीक है? If in case you have a doubt, we can discuss it.